Hello. This video is going to be about the area between curves. This will be the presentation of the area between curves. We have a function f of x, which is on the top, and we have a function g of x, which is on the bottom. So I want you to stop the video and think about how it's going to be possible to obtain the area between these two curves. Once you have an idea, you can continue with the video. So now you probably know that the formula to obtain the area between the curves is a subtraction of the area of the function on the function on the other minus the area of the function under the other. So in this case, we have to do the integral from a to b, which are the limits of integration of the integral of f of x minus the integral of g of x. An important part of this formula is that you can do the subtraction of the two functions first and then the integral. First case, one of the functions is above the x-axis and the other is below the x-axis. This will be the graph of the case number 1. Okay, the second case is the area of the region bounded by two curves that have two intersections. This is the graph of an example of that case. And the third case is the area of a region bounded by two curves that have more than two intersections. This will be like an example of the graph of two curves with more than two intersections. In this case, we have three intersections, one over here, and one over here. Good news is that the three cases are solved with the same subtraction of the functions. The only difference is that we have to use in this case, this last case, two different subtractions, because from -8 to 0, the function f of x is on the top and the function g of x is on the bottom, but just after 0, from 0 to 5, the function g of x is now the top function, and now f of x converts into the bottom function. Let's solve our first example. We have two functions. The first is x squared plus 2 and the second is -x plus 1. So remembering what we know about functions, the first function, x squared plus 2, it's a parabola that opens upwards, and the vertex of the first function, which is also the y-intercept, is at 2. So we have a function opening upwards with vertex at 0, 2, will be something like this. Okay, the second function, it's -x plus 1. It's a linear function that intersects the y-axis at 1, which is the independent term of the function, and has a slope -1. The slope is the coefficient of x. So slope -1 will be something like this. And we also have the two limits of integration, which are 1 and 2. So we have to take in account limits of integration 1 and 2. This is 1 and this is 2. So if we draw the limits of integration, what we will have to do is obtain the area, this area over here, which is going to be the integral from 1 to 2 of the upper function, which is x squared plus 2, minus the lower function, which is -x plus 1 times dx. Okay, we can first subtract the two functions, so we will have x squared plus x plus 1 times dx. And then solving the integral, it will be x cubed over 3 plus x squared over 2 plus x from 1 to 2. By substituting the upper and lower limits of integration, we will have that x cubed, it's 2 cubes, so it will be 8 thirds plus 2 plus 2 minus 1/3 plus 1/2 plus 1. And if you do all the substitutions of the upper and lower limit, the result or the final answer will be 29/6 of units squared. So this is the final area between the two curves. On our second exercise, we have two functions, x squared and 3x. Again, it's a parabola that opens upwards with vertex at 0. So it will be something like this. And the other function, it's a line that crosses the x-axis again in 0 and has a slope 3. So 1, 2, 3, 1. So this will be the second point. It is something like this. And what we have to do is obtaining the area between these two curves. So first thing you have to do is which is the upper and which is the lower function. And if you do the graph, it's very easy to know that the upper function is now the linear function. And the intersections of the two functions gives you as a result the limits of integration. So this integral will be the integral from 0 to 3 of 3x, which is the upper function, minus x squared times dx. Another way to know which of the functions is the upper and which is the lower, if you don't want to do the graph, is by substituting a value between the two limits of integration. So in this case, for example, we can substitute the value 2. If you substitute 2 on the first function, you will have 2 squared 4. So when x equals 2, y1 equals 4. And using the same x value, if you substitute 2 on the linear function, y2 will be 6. So 6 is greater than 4. You can conclude that the upper function is the linear function. So by doing the subtraction of the two functions, you have to obtain the integral from 0 to 3 of 3x minus x squared. The integral is 3/2 of x squared minus x cubed over 3 from 0 to 3. So by doing all the operations, substituting the upper and the lower limit, you will have that you have 27/6 square units. And last but not least, we are going to solve an exercise in which the two functions intersect each other more than twice. This is a polynomial function, x cubed minus 4x, and a linear function. Let me show you the graph. So this is the graph of those functions, the polynomial function and the linear function. And as you can see, these functions intersect each other 3 times. One at -3, the other one in 0, and the last one in 3. So what you have to do is obtaining first this area over here, which is going to be the integral from -3 to 0 of the upper function, which is x cubed minus 4x, minus the lower function, which is 5x, times dx. And we can simplify this as the integral from -3 to 0 of x cubed minus 9x times dx. And this will be the first area. What about the second area? Second area, which is this, will be the integral from 0 to 3 of now the upper function, which is 5x, minus the lower function, which is x cubed minus 4x times dx. So area 2, or the red area, will be from 0 to 3, negative x cubed plus 9x times dx. And as you can see, as the function is a symmetric function, obtaining one of the two areas and multiplying times 2, we will obtain the total area. So if we solve the integral, we substitute the upper limit. Well, first we do the integral of x cubed minus 9x, which is x to the 4 over 4 minus 9/2 of x squared. And then we substitute the upper, which is 0, and then the lower limit, which is -3. And it is very important that you check that you substitute first the upper limit always, and then minus, and then you substitute the lower limit. If you substitute on the opposite direction, you will have a negative area instead of a positive area. So the first substitution is 0, and the second substitution is negative 81/4. So negative times negative is positive, so the area number 1 is 81/4 of units squared. And as I have already told you, as you can see, as this is a symmetric function, the area number 2 is going to be exactly same 81/4. So we will have an area of 81/4 plus a second area, this is the total area, plus a second area which will be also 85/4, which give you as a result 162/4, which is the same as 81/2 of units squared. So the area between the two curves is 81/2 or 81/2 units squared. Okay, hope this video have been useful. Now you can continue with your set number 15, which is area between curves. Remember that you have to have an idea always on the graph so you can know which of the functions is the upper function and which is the lower function. And also the limits of integration are given by the graph. In case that you don't want to do the graph, another way to do it will be equating the two functions, and obtaining the result of that equation will be the two intersections or three intersections of the two functions, and those will be your limits of integration. I see you tomorrow.